Welcome back. And so as we continue, um, on the second line we can see the optocoupler. So these are the optocouplers that we have, and there are also packages. Now these are the different packages that we have: TO, 220 and 92. Now these are typically used for transistors. Now that's a crystal. You also have the potentiometers. These are the different types of potentiometers: trim pot and the Bones trim pot potentiometers. We have the regulators, also the voltage regulator that we are seeing, and we also have inserted a voltage regulator out here. Now that's a 555 timer that we've used, and so that's a voltage regulator. These are the resistors that we have. That's 0.1 stand-up resistor, and the resistors with different rating. You can also create your own custom resistors and other components, which I'll be showing you all in upcoming videos. And then you have the sensors, that is photoresistant phototransistors, of course. This is shape. Now what are these shapes? Now yes, we need these shapes so that we can identify as to what is the next stage. If you want a power symbol, you can use this. You can if there's a push button switch out there, you can click and say that's a power symbol, and you can then also use the recycle symbol. So these are the symbols, shapes that they have used. Then you have the SMD2, surface mounted devices. These are the different chips that are available to us, the tantalum ones and the molded ones. And then that's an SMD IC as we see them. These are the different ICs that we see here. Now we do not have the numbers on these ICs, of course, but those will have to be added, depending on the electronic schematic that you have produced. So the electronics schematics that you produce, you will be using those SMD ICs. And these are the different switches that we have. A long list and variety of switches. You have the push button ones, and these are some of the Omron made switches for push buttons. This is a multiple choice, ultra miniature also, and the DP/DT toggle switches. That's a relay out here that we see. So typically these are all the components that we are seeing, and of course lastly that's the transistor. Out in the transistor again we have the T0, TO32, not 32, 92, sorry, and SOT23. So these are the different packages that we are seeing here for transistors. So out here these are the categories of the parts that we can use for our PCB design. So this is what we have as far as the parts part menu out was concerned. The next is the trace menu that we are seeing here. Out here on the trace menu, click on that and you can click on you can see smart layer change. It may automatically switch to a different layer if you start a trace by clicking on an existing element. That's a smart layer change, and if this option is not checked, or if you start drawing the trace on an empty space, then the currently chosen layer is honored. Which means so if you deselect it, then it can go and draw the trace on the other part also. Oops, excuse me. So it will go and draw the trace on the other layer also. And here this is smart thickness change. Again, it's the same thing as the layer change. So when we click off the thickness change, it may automatically switch to a different thickness if you start a trace by clicking on an existing element. Okay, so if I'm supposedly out here, if I'm having a trace, okay, out here I'm having this trace. And now if I'm having this trace, okay, this thickness of the trace will continue when I draw a trace. When I draw a trace from here, from here until here. So this thickness will continue. If I want to change the thickness, then I'll come here and I'll deselect the thickness change. Okay, so this can be taken care of. Out here it's mentioned, of course, if this option is not checked, or if you start drawing the trace in an empty space, then the currently chosen thickness will stay. So if this is not, so depending upon the trace, I mean, depending upon your choice, it can even choose to have the change in the trace thickness or the layer change if it's selected or if it's clicked or ticked as we see it. Next is the line. Now when we say a line, what do you mean by a line? It's a normal line that we are drawing here, that's it. And so that's the line that we draw. Why did we draw a line? It's just something that is part of the overall circuit design that we want to have. Much the same way, if you want to draw a rectangle, you can click on that and draw a rectangle. Now why are we doing this? Because if you want to have a power plane or a ground plane, like, now the top of a layer, generally we select the power plane as a red colored and the ground plane with green color. So if you want to draw any power plane in any particular part of the circuit, then you can always do that way. So these rectangular or polygon or arc, as we see, these are the different arcs that are available to us. If I select this arc, so this is how your arc will appear as or look like. Now this is how you draw the arcs that are available to us. Now each of these arcs, what is this? This is an angle at 0 degrees, sweep 360 degrees. So this is a proper circle. Again, this is also what angle is, what 180 degrees, sweep at 360 degrees. So these are the different types of arc that you'll be able to draw. Out here, if I come and I stretch it here, so this is how your arc will appear and look like. So these are the different arcs that we are drawing here. I'm retaining these arcs and everything on this because this particular PCB board that I'm using, it's like some kind of a work board on which I would like to show you all different things. If you're not dedicatedly drawing any circuit here, we are not designing not a circuit, sorry, a PCB. We are not designing any board as such. I'm just demonstrating the different features here. And then you have the ellipse. So if you click here and if you draw the ellipse, this is how your ellipse will come. But again, as I said, why do we need these? Because if you want these components to be part of a power plane or a ground plane, then these become handy for us. So this is the reason that we are drawing it. Click on image now, add an image of tracing or etching at home. It won't appear on manufactured board. Alternatively, copy an image in other program and paste it. So now out here, that's the image that is there. So if you want to use any of the images, are there any images? No, we don't have an image. Let's click on pictures, save pictures. No, there are no saved pictures either. Just picking any random image. That's an image that I'm having. So suppose if I click on open, well, this is how your image will appear and look like. Okay, this is how your board, the image will appear on the board. Of course, we're not using it, so I'm deleting it, so it could look scary. So you can import a bigger or smaller image, that's fine. And out here you can add a comment or error, so won't appear on standard printouts or manufactured boards. But out here, if you mention it that this note is what? The note here is it was a 48 pin DIP, 48 pin DIP. Okay, and that's it. Close that. Oh, this is the second note that came up, but if I come here, If I click on this and I delete it, and if I come here, when you double click on that, it will show you what is the note about, and if you wish to modify it, you can again make a change and modify it here. I'm closing this here. So if you drop any notes over here, and if you move it, you can move it also anywhere on the board that you want it to. So you can add a note, and there is a continuity on click on electrically conductive element to see what it connects to. And so if I click here, and suppose I click on here, so it is telling me like the whole diameter specification. But more importantly, what is it that I was wanting to do here was, it is showing me the connectivity as to where the connection is going. Okay. So when I select the continuity button here in tools, okay, it will tell me as to where all does that particular pin connect to. So if I click on this, it is showing me that this pin goes from here and connects at this pin. So that is what this function is about. Oops, Control Z. When you click on pin, you can see that these are the colors and options that get activated. These are the options: underflow, overflow, select. That's the color. So out here, this is the color that is showing up. And this is the overflow for detection of electrical shorts when you left click on conductive element. And this is an underflow. When you click on this, that's for underflow. So that is what we had as far as the continuity element was concerned, continuity factor was concerned. Net connection. So click on net connection here. So it is showing me where do we stand on this. Click on validate net list. No, we are not come here yet. If I click on a pad to see what it connects to in the schematic file. So I'm clicking here. And when I click on this particular pin, it will show me as to where does this connect to, okay, on the schematic. So that is the net connection that we see here. And what are the other things? Yeah, validate the net list. We can validate the net list using what? Power supply schematic. Let's click open. It was linked successfully. Okay, it will be used to validate the current layout. Click OK. So now it is showing us are there any errors in the description? Yeah, there are extra connections are there. Yes, there are some more connections that we have. So typically it is netlist validation, and it is showing us the error descriptions out here. Okay, and you can validate the edits if you have made any changes here, and if not, then that's fine. You can also export the error report. When you click on that, yeah, a file will open, MS Excel file, in which you'll have the list of errors that are coming, but a list of errors that are there, but it's okay, we don't need it yet. So this is what you had as far as the tools are concerned. Okay, and in the next session we'll take a broader look at most of the other options that we are seeing here in terms of the part descriptions and the shapes and all. We have discussed some of these points earlier. We'll take a little bit closer look in the next video. Till then, thank you and enjoy the